Today we are going to see matrix, and purely it is known as matrices. So in this chapter we are going to see what is a matrix, what are the different application of matrix in real life. Next we are going to see order of a matrix and types of a matrix also. Next we are going to see matrix operation. Generally we know arithmetic operation, plus, minus or multiplication also. So same operation we are perform on matrix also, that is a matrix addition, matrix subtraction and multiplication by a scalar to a given matrix also. Next, see what is a matrix. Now see the image here. See, in this image we have rectangular array. In rectangular array we have numbers 5, 9, 4, 2, 1, 8. These numbers are called entries or element of matrix. So these numbers are enclosed in a rectangular array, and these numbers are arranged in rows and columns. So vertical arrangement of numbers is called columns. In this case we have three columns. First column having element 5, 2, second column having element 9, 1, third column having element 4 and 8. Similarly, horizontal arrangement is called rows. In rows, here we have two rows, and first row having element 5, 9, 4, second row having element 2, 1 and 8. So matrix is a arrangement of numbers. It may be a real number, it may be a complex number also, or it may be a expressions also. So what do you mean by matrix now? What is the definition of matrix? Now let's see. A rectangular arrangement of numbers or expressions in rows and columns, that is called matrix. In this matrix we have three columns and two rows. So number of rows here are 2 and number of columns here are 3. Now we are going to see what are the different application of matrix in real life. So why we are going to study matrix, what are its real life application. Now first, see, matrices are used in many fields such as engineering, economics and in medical field also. Graphic software such as Adobe Photoshop, already we know Photoshop is a photo editor tool, that is a software used to edit the photos. So in this software or Adobe Photoshop, matrices are used to process linear transformation. In hospitals, medical imaging, CAT, CT scan and MRIs uses matrices to operate. Many IT companies, that is information technology companies, also uses matrices as a data structure to track user information, perform search queries and manage database. In encryption, we use it to scramble data for security purpose. To encode and decode this data, we need matrices also. So all these are the application of matrices in real life. So it is very important to learn matrix, how we can apply this concept. So next we are going to see what do we mean by order of a matrix. Order of a matrix means each order define the size of matrix, how many rows or columns it has. So order gives the number of rows and number of columns in a given matrix. So that is R into C, R by C. Generally it is read as R by C. Order of matrix is generally read as R by C. So now see the example. R denote the number of rows and C denote the number of columns. Now see here example, we have a matrix having elements 6, 2, minus 1, minus 2, 0, 5. In this matrix we have first column 6, 2, 6, minus 2, second column 2, 0 and third column minus 1, 5. These are the three columns, and row, first row 6, 2, minus 1, second row having element minus 2, 0, 5. So in this matrix we have two rows and three columns. So order of matrix is already we know R by C. So two rows and three columns. So order of this matrix is 2 by 3. It is read as 2 by 3. That is the order of this matrix. Now we see some examples regarding the order of matrix also. Now see first example. In this example how many rows are here and column? We have 3 rows and 3 columns. So order of this matrix is 3 by 3. It is also called square matrix. In square matrix, number of rows is equal to number of columns. So order of matrix is 3 by 3. Next, in this case, how many rows here? We have 3 rows. And how many columns are here? We have 5 columns. So our order of matrix is R by C, that is 3 by 5. It is a rectangular matrix. Next matrix, 2 rows and 2 columns. So order here 2 by 2. That is a square matrix again, because number of rows is equal to number of columns. Now see one more example. Here we have how many rows? 4 rows. And how many columns are here? Only 1. So order of matrix is 4 by 1. Here it is called column matrix because it has only one column. Next, 9 minus 5 7 0. In this case we have only one row and 4 columns. It is called row matrix. So order of this matrix is 1 by 4. 1 gives the 1 tells us the how many rows are there, and 4 gives the how many number of columns are there. That is the order of matrix. All of you easily got what do you mean by order. Order of matrix define the size or type of the matrix. Next we see operation on matrices. So already I told addition, subtraction and multiplication are the operation on matrices. Now see how we can add two matrices. To add two matrices, they must have the same order. That means number of rows is equal to number of first matrix is equal to second matrix. Number of column in first matrix is equal to number of column in second matrix. So R into C must be equal in both the matrices. That is order of both the matrices must be same. So to add the two matrices, we have to add the corresponding entries. We have to add the corresponding entries. Now see here example, we have two matrices 5 minus 3 minus 3 4 0 7. So in this case first matrix having first element 5, so second matrix corresponding element is minus 2. So we have to add these two elements 5 and minus 2, 5 plus minus 2. Now this is the addition of corresponding element. Now we see one more example. Now see this is your first matrix 8. First row is 8 0 minus 1 3. Second row having element minus 4 minus 5 4 2 9. So in this case order of this matrix is R by C, that is 2 by 4. Now second matrix, order of second matrix is also 2 by 4. So order is same, so we can add these two matrices. In this case we have to add corresponding element. So what do you mean by corresponding element? Corresponding to 8, which element is there? Minus 1. So we have to add 8 and minus 1. So 8 and minus 1 are corresponding elements, so we are adding 8 and negative 1. Next, corresponding to 0 we have 7, so we add these two elements. Corresponding to minus 1 we have 5. Corresponding to 3 we have 2. This is the first row. Similarly in second row we have minus 5 plus 5, 4 plus 3, corresponding to 2 we have 3, and corresponding to 9 we have minus 2. So in addition of matrices we have to add corresponding element if we are doing addition. If we are doing subtraction we have to subtract corresponding element. Now next we have to do the addition here. 8 plus minus 1 it gives 7, 0 plus 7 gives 7, minus 1 plus 5 gives 4, 3 plus 2 gives 5. Next minus 5 plus 5 gives 0, 4 plus 3 gives 7, 2 plus 3 gives 5, 9 plus negative 2 gives 7. That is the addition of matrix. So in this case we are going to add corresponding element, that is the addition of two matrices. Next, similarly we are going to see subtracting two matrices. Similar to addition, we are doing the subtraction. Here we have to subtract corresponding entries or corresponding element of the matrices. So the condition is same as addition, and order of the matrices must be the same in this case, similarly as addition. So to subtract two matrices, they must have the same order. You simply subtract corresponding entry. Now we are going to see the example. See, this is example. We have to subtract the corresponding element. So 9 minus 4 minus 2 minus 0. So it gives the subtracted matrix 5 minus 2 minus 3, that is a resultant matrix. We see one more example with more explanation also. See here two matrices. First matrix 2 minus 4 3 8 0 minus 7 1 5 0, and second matrix 0 1 8 minus 3 minus 1 1 minus 4 2 7. In this case, order of first matrix is 3 by 3, second is also 3 by 3, so order is same, so we can do the subtraction also. Now see, we have to subtract corresponding element. So corresponding to which element is there in second matrix, that is a 0, so we subtract 2 minus 0 here, we can do this subtraction. Next, minus 4 and 1, corresponding to minus 4 we have 1, we do this subtraction also. Next, 3 minus 8, next corresponding to 8 we have 3, and so on. We get 5 minus 2, and lastly corresponding to 0 we have 7, 0 minus 7. So resultant matrix we get 2 minus 5 minus 5 5 1 minus 8 and 3 minus 7 lastly. This is the subtraction of the matrix. This is the resultant matrix. So that is the subtraction of two matrices. Next, we are going to do multiplying a matrix by a scalar. So see, in matrix algebra, a real number is often called a scalar. To multiply a matrix by a scalar, you multiply each entry in the matrix by that scalar. Now we see the example here. See, we are going to multiply 4 to a given matrix. In here, order of matrix is 2 by 2 because it has 2 rows and 2 columns. First row is minus 2 0, second row having element 4 minus 1. This matrix is multiplied by a scalar, that is a 4. So in this case we have to multiply to each entries. We have to multiply to each entry or each element of a matrix by 4. See, 4 minus 2, 4 into 0, 4 into 4, 4 minus 1. So we get a resultant matrix, that is minus 8 0 16 minus 4. Now we see one more example here. See, here we are doing addition as well as scalar multiplication in this matrix. So here we have two matrices, 1 minus 2 0 3, that is the first matrix. In second matrix, first row is minus 4 5, second row is 6 minus 8, that is two matrices are enclosed in bracket. So first we add these two matrices, order of these two matrices is same, so first we are doing addition. See, we add the corresponding element. 1 addition to minus 4, 1 minus 4, next minus 2 plus 5, next 0 add with 6, 3 addition with negative minus 8, and scalar as it is minus 2. Now see, minus 2 scalar as it is, we have done the addition of matrices here. Next we have to multiply each element of matrices by a scalar. So minus 2 into 3, we have to multiply minus 2 to each element of a given matrices. So minus 2 into minus 3, next minus 2 into 3, minus 2 into 6, minus 2 into minus 5. So resultant matrix is minus 2 into minus 3 we get 6, minus 2 into 3 we get 6 also, minus 2 into 6 we get minus 12, minus 2 into minus 5 we get 10. That is the multiplication of a matrix by a scalar.